Hey Hannah. All right, so here's the problem. I set it up here, and it's that exact same thing, just like number 12 on that worksheet that we were talking about. It was talking about Becky, and we were trying to figure out um, we were trying to figure out the distance if she just walks straight to that point, and we're talking about straight to this point. So essentially, where she started and where she ended up, we want to figure out that direct line. Well, the very first thing that we want to figure out is going to be that component form. And if you remember that component form, it has it looks like this, and then it has x1 and then y1, and essentially there would be a point. So we want to figure out what that component would be right here first, and then we would find the distance. Okay, so in order for us to do that, we want to use our trigonometry, okay, to figure out the whole distance here, okay, all the way up to that point, and the distance across. Because basically what that component form is, it's just a point on a graph, if you want to think of it like that. Okay, so the very first thing I want to do is I want to figure out, notice I have a right triangle here. And my right triangle, you can see it looking right here. Here's a right triangle. What I want to do is I want to figure out the rest of this length here. If I can figure out that length, I'd be able to add it to my 2.2, and I'd find the length of the entire that entire height, essentially. Okay, so how could I figure out that? Well, remember when we talked about, we knew the measure of this angle right here is 15 degrees. Okay, so how could I figure out x if I know that this angle is 15 degrees, I know the opposite angle, and I knew the hypotenuse of the triangle? Well, I could use sine. Remember, the sine, so is going to be the opposite over the hypotenuse of 15 is equal to x over 3.1. All right, so I set it up just like I did opposite over hypotenuse. I'd multiply, I want to get x all by itself, so I'd multiply this entire thing by 3.1. Essentially, they would cancel out over here, which means I'm multiplying there. So now I have 3.1 times the sine of 15, and that's going to equal x. Okay, and when you multiply that out, x is going to equal roughly 0.8. We did talk about that a little bit, and we did come to that 0.8. So this green section, okay, right here, this green section of the problem is going to be 0.8 kilometers, which means the entire distance, or the entire height, is 3 kilometers, because I just took that 2.2 and I added 0.8 to get 3 kilometers. All right, so I figured out that bottom portion of it, added that to 2.2, and I got 3 kilometers. Now what I have to do is I have to figure out the distance east. So I just figured out the distance north, okay, from the bottom part up, okay, up to the top. Now I want to figure out the distance east here. I want to figure out that red line. So I'm going to erase this, what I just went over. Okay, so now based on this information, this distance east is my x. Okay, I just figured out my x is 0.8, going that short side of that right triangle, going north. Now I have to figure out the distance east that Becky went. So how could I figure out that? Well, again, this angle is still 15 degrees, and now I have the adjacent and the hypotenuse. Okay, so I would do, what would that be if I went adjacent over hypotenuse? That's cosine. So I find the cosine of 15 is equal to 3.1, or sorry, x over 3.1. Again, I have the adjacent over that hypotenuse. From here, I take the exact same step, and I multiply by 3.1, multiply by 3.1, and I get 3.1 times cosine of 15 is equal to x. Okay, so when I type that into my calculator, I get an answer of and I'm just going to leave it at 2.99. Okay, 2.99. So this distance east, where my x is right here, okay, that's going to be 2.99. All right, and now I'm going to make this a little bit easier. I'm going to erase a few things. Okay, so if you want to take a look at this right now, I'm just going to erase it quick, and then we'll cover what we know. All right, so now looking at this is a whole new setup here. Okay, so now I know that my distance east is 2.99 and my distance north is 3. Okay, so when I put that into my component form, I get I get 2.99, 3. Okay, and now what I want to do is I want to figure out that distance of that green line. Okay, and this is the middle step that I was missing, or we were missing. Okay, in order for us to find the distance of that line, very simply, we use the distance formula. Okay, if you remember the distance formula, my distance formula is going to be, my distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's my distance formula to find on a coordinate graph. Now, I know my x2 and my x2 and my y2. Okay, that's going to be my component form. If you look at that, that's essentially going to be a point. Okay, so my 2.99 is my x2, my 3 is my y2. So all I do is I plug that in to what I know. All right, so now I have the square root of 2.99 here, okay, squared, plus my 3, and I'm going to square that. Now, the question is, what's my other point? And my other point is my starting point. Remember, we started at 0, 0. So I'm going to take that, that's 0, 0, and I subtract from 0 on each side. Okay? So, and that's going to be the distance that she traveled. Okay, if we just, remember when we talked about as a bird flies, it's just the distance going across. So when you square 2.99 and then you add that to 3 squared, you're going to get like 17.9401. Remember, we then have to take the square root of it, and we get roughly 4.2 kilometers. And that's where that 4.2 came from. All right? But it also asks us to find not just the distance, but the direction. Okay? And when we find the direction, that's going to be an angle measure. Okay? So now, if we simplify this just a little bit, so if you need to write this down, pause it and write it down quick. I'm going to give you a second and I'll simplify it. Okay, so here it is. Now, we still have a right triangle here. Notice we have our right triangle right there. Okay, and now what we want to do is we want to find it's an angle measure. We want to find this angle measure, okay, and we're going to be going, again, still north and east. All right, so now what we have to do is we use our new 3 that we figured out and our new 2.9, and we are going to find the inverse tangent of 3 over 2.99. Remember, TOA, meaning opposite over adjacent. Okay, so if you take the inverse tangent of 3 over 2.99, you will get 45. And remember, whenever we take the inverse of one of our trigonometry symbols, that's going to become a degree. And now what we have to do is we have to figure out which direction is she walking into, and that's going to be north and east. Notice she went north and east. Okay, I believe your teacher would also just take 45 degrees, but that works. Okay, so you need to figure out, the key is to figure out this point right here first, which was our 2.99 and 3. You need to figure out that ending point first, and then go get the distance formula to figure out that distance from the beginning to the end. Okay, I hope this helps out. Sorry it was a little bit long, but I hope you have a great night and good luck on your test. Let me know how it goes. Good luck.